guys, so this is just a quick little tutorial on how to complete this worksheet using formula mass and calculating. You're going to need a couple of things to do this. You're going to need your periodic table. If you need one, you can find one on the topics page under chemistry resources. You need a calculator, and you may need your ions list. There are several compounds on this sheet that we have not covered from the last unit, and I'll be going through this tutorial and kind of marking out some things and making some notes, so make sure you watch the full video. So let's just do a couple of these just to kind of show you what you need. Like I said, you need your periodic table, ions, and calculator. So let's just do number one real quick. Okay, so this is a binary covalent compound, and I know that because of the prefixes here. I don't know why this is not. Oh, there we go. Okay, so it is working now. Okay, so binary covalent, dichlorine heptide. So the first thing you need to do on the line is write the formula. So dichlorine, oh, and my pen keeps going on, that's why it is. Heptaoxide. Okay, so this is the formula. Once you get the correct formula, then you need to vertically list the elements and include their numbers of atoms. So in this formula, you have 2 chlorines and 7 oxygens. Now we need to go to our periodic table, and what we're doing is we're looking at the mass. Sorry, you can hear my kids in the background. We're looking for the mass of those. Now, some textbooks you will keep the first 4 numbers, okay, up to 2 decimal places. For this activity, I just want you to keep the whole number. Okay, and so chlorine's going to round to 35 even. Oxygen, because it's 15.9994, it's going to round to 16. Okay, so let's go back. We're going to use those masses. Oh, and there was the key, obviously. Let me find out where. There we go. Okay, so chlorine we said was 35. So we're going to multiply the mass of 1 chlorine by how many atoms we have. We have 2. And we're going to do the same thing for oxygen. Excuse my handwriting on this. Okay, then we're going to go to our calculator. We're going to calculate those. So 2 times 35 is 70. Okay. 7 times 16 is 112. And then to get the final molar mass of the compound, we add these up. So 112 plus 70 is 182. The units for this are going to be grams per mole. Now at the bottom of this, you will see a key. Keep in mind that this key was created using decimal places as well when we did our initial masses. So as long as you get close to that number, you should be good. And like you saw earlier, I do already have a worked out key of this made that I will post in attachment to this. So let's try another one that's ionic, and let's go to number 4. And I'm choosing number 4 because this is actually a hydrated formula. We did not learn hydrates last unit, so you can ignore the last name on that, dihydrate, and let's just focus on plumbic oxalate. Okay, so this is an ionic compound. This is where your ions list is going to come in handy. Plumbic is a Pb4+. Oxalate is C2O4 2-. Once again, if you need to go to your ions list to find those, find them. Okay, now remember when you put this compound together, it's a matter of balancing the charges. We have a 4+ ion here and a 2-. And so you can do the crisscross, but if you do the crisscross method, make sure that you reduce. If not, we just want to balance the overall charge. So we need 1 Pb ion for every 2 oxalate ions. Because oxalate is a polyatomic ion, we do need to put it in parentheses, and since we need 2 of those, the 2 goes outside. Now once I write a compound for that properly, then I can go back and do the mass. So we've got 1 lead, we've got a total of 4 carbon, and 8 oxygens. Okay, we go over to the periodic table again, find the masses of those. So lead is 207, oxygen was 16, carbon is 12. Okay, and it'll take you some time to get used to finding those masses pretty quick. So since there's only 1 lead, this one is 207. There's 4 carbons at 12 each, and 8 oxygens at 16 each. Okay, so obviously 207 times 1 is itself. 4 times 12 is, I know I should probably have this memorized, but I don't do mental math very easy. 48. 8 times 16 is 128. Once you get the individual masses, add them up. So 207 plus 48 plus 128. And you get a total of 383 grams per mole. Now, once again, because this was a hydrate on my original one, the mass of that is going to be a little different. So number 4 with the hydrate would weigh 419, but we just did that mass. Okay, so let's quickly go through the ones that you might have difficulty with, and I'll go ahead and give you those formulas. These all top ones, you should be good. Look at number 10 real quick. Oxygen gas. Remember, oxygen gas is one of your 7 diatomic elements, and so its formula is going to be O2. Scrolling down a little bit, 21 and 15. Okay, so acetic acid, its formula is HC2H3O2. Nitric acid is HNO3. We did not get to acids last unit, and that's okay. I will give you those. And then scroll down to the very, very bottom, number 25. You can do ammonium permanganate, but ignore the pentahydrate. Once again, that mass for 25 will be different. Okay, hold on, baby.